Hey guys, so in preparing for your take-home test that you are doing for chapters 4 through 8, that's 5 chapters, 4, 5, 6, 7, and 8. That's a big chunk of material. So hopefully you guys have been keeping up with the reading and with the homework, because that's really the best way to study. But just to help you focus in a little bit more on things that you will need to know for the test, I'm making this little review video. So I actually have the e-textbook pulled up here, and I'm just going to flip through the pages. I also have the test in front of me, so I will sort of highlight for you the things that you need to know from each of the chapters, and hopefully this will help you hone in on your studying in the last couple of days until the test. Okay, so chapter 4 is all about introduction to organic compounds. I don't know why these things are highlighted. I didn't highlight them, so ignore the highlighting. But things that you need to know from chapter 4. So I already kind of tested you on alkanes, alkenes, alkynes, that kind of a thing. But things that you need to know for this test, you need to know how to draw the different types of structures. This is a bad. Here we go. You should know this. You should know molecular formula, condensed structure, Lewis structure, skeletal structure, and you should know how to draw the condensed structure, Lewis structure, and skeletal structures of different compounds given the name of the compound or given the molecular formula. You should also know I don't have anything about fatty acids. Going through, this stuff, the organic families of the functional groups. You should be able to do problems where you can, if I gave you a bunch of chemicals and I said identify this, if I identify an alcoholic functional group, circle all of the carboxylic acid functional groups, etc. So basically know how to use these tables to identify functional groups in molecules. So for instance, if I gave you this molecule right here and I said identify the amine group, I would expect you to be able to circle it, that kind of a thing. So again, it's open book, so you will be able to use this table, but make sure that you know how to do that kind of a problem. And just trying to flip through and see, let me flip through my book and see if there's any specific types of problems from the chapter that. Okay, here's some. At the end of the chapter, 444 to 447, have you practice identifying functional groups. Okay, so make sure that you can identify functional groups. So that's section 4.4. Okay, I'm going back, now I'm going forward. Section 4.5, isomers. This one I will definitely be hitting up. I want you to I want you to know what isomers are, first of all, in general. What is an isomer? And you should know the difference between structural isomers and conformational isomers. You should also know how to name organic compounds. So the nomenclature section, that's definitely going to be on there. How to name organic compounds. So know that whole section, this whole section here about naming. All right. And also know the second part about isomers, being able to identify cis and trans isomers is the other type of isomers you should know. Okay? And I think the last thing in this chapter, knowing how to identify cis and trans isomers. And then the last thing is we talked about stereoisomers and enantiomers. And in order to be an enantiomer, in order to have an enantiomer, a mirror image that's non-superimposable, molecules have to have chiral carbons. So make sure you understand what a chiral carbon is and how to identify chiral carbons in molecules. And that's the end of chapter 4. Okay, so nomenclature, identifying functional groups, writing the different types of structures, Lewis structure, condensed structure, skeletal structure, and the different types of isomers, including chirality. That's what you should know from chapter 4. Okay, I'm not going to ask you questions about fatty acids from this chapter, and I'm not going to ask you about, this is the summary section, I'm not going to ask you about the difference between alkanes and alkenes and alkynes. So, but you do need to know how to name stuff. Okay, moving on to chapter 5. Okay, so chapter 5, it's all about the carbohydrates. So, obviously it's open book, so you can look up what the different carbohydrates are, types of carbohydrates are. Oddly enough, I don't have you identifying primary, secondary, tertiary alcohols, so you don't need to focus on that. What you do need to know, though, is how to draw Fisher projections of different molecules. Okay, that's on this section here, Fisher projections. And you also should know the different types of stereoisomers in this chapter. So there's enantiomers, diastereomers, and epimers. And I will have a problem where I ask you to draw those things. So know what they are, do some problems like these here, where you practice doing enantiomers, diastereomers, and epimers, okay? You do need to have an understanding of oxidation and reduction reactions, also known as redox reactions, section 5.3. So given a reaction, you should be able to indicate which agent is the reducing agent, which is the oxidizing agent, which thing gets oxidized, which thing gets reduced, etc. Okay, so judging by the chemical reaction that I give you, you should be able to identify those things, the different, what gets reduced and what gets oxidized. So you need to understand the concept of oxidation and reduction. As for this section on ring formation, monosaccharide ring formation, what I want you to, you don't have to, there's some problems in the chapter that ask you, like for instance here, or no, I thought there were some that ask you to, like, okay, for instance, it asks you to write the Pyranose ring form of this structure, so to turn this straight structure into a Pyranose ring. You don't need to know how to do that for the test, so if you want to ignore those problems in the chapter, that's fine. These are the problems you should focus on. You do need to be able to identify the alpha anomer and beta anomers. So you should know what anomers are and how to identify alpha and beta anomers of sugars. Okay, so these are some good practice problems here. This sample problem here, and there's probably some in the back of the chapter as well. I'm not going to ask you any questions about disaccharide linkages in like this, that you're not going to have to write any reactions or anything, but you should understand from this section about disaccharides about condensation and hydrolysis reactions. Essentially, understand the definition of a condensation and a hydrolysis reaction, understand how to identify condensation and hydrolysis reactions, some good practice problems here, the sample problem here that was in the lecture, and also there's probably some on the next page, maybe not, maybe at the end of the chapter there's some more. Nope, here we go. Here's some practice problems that have you practice condensation and hydrolysis reactions. So those are very good practice. And then the polysaccharides. I will ask questions about the different types of polysaccharides. So make sure you understand both the different structures of the polysaccharides and their different purposes, their different functionalities, and how their structure equals function. Okay. So that's this whole last section, 5.6. Know that section. And then I do have a question also about carbohydrates in the blood and about compatibility, blood compatibility. So understand this chart here, essentially. What types of blood can be donated and accepted by different people with different blood groups. So a good sample, these are some good practice problems here. The sample problem and the practice problems about ABO blood groups. Okay, so that's pretty thorough. I pretty much have a question from each section of the chapter. By the way, the test is 35 questions. It's 7 questions per chapter, and I tried to touch on a little bit of everything in each chapter. So just a heads up there. So on to chapter 6 now. Chapter 6 is all about solubility and intermolecular forces. So, well, I guess it's really all about intermolecular forces. Solubility is the next chapter. Okay? No, they're both. It's both. So you should understand the different types of intermolecular forces and be able to explain what each one is. Which ones are strong, which one is strongest, which one is weakest. Again, this is all open book, so you all should be able to do very well. But if you haven't done the work leading up to it, it might be much more challenging. 35 questions over 5 chapters is going to be a lot of work if you're not prepared. So, all right, understand how hydrogen bonding occurs. Understand what a hydrogen bond donor versus a hydrogen bond acceptor is. Be able to identify which molecules can engage in hydrogen bonding and be able to draw hydrogen bonds between molecules. So this sample problem is really good. Drawing hydrogen bonds is a really good sample problem here, and any practice problems that are like that. So I'm looking for some. I'm not seeing any ones here where they ask you to draw the hydrogen bonds, but make sure you know how to draw hydrogen bonds. Identify hydrogen bond acceptors and hydrogen bond donors, and draw hydrogen bonds. You should understand the concept of solubility and how intermolecular forces influence solubility. And you should understand what kinds of compounds are soluble with each other based on the golden rule of solubility. You should understand how soap works, the components of soap molecules, and how it works to remove dirt and grease from dirty things. So I don't really actually have many questions on predicting solubility, on predicting whether two things are soluble in one another. I do, however, have some questions on intermolecular forces and boiling points. So make sure you understand how intermolecular forces affect the boiling points of different compounds. So here's a good sample problem. This one, problem 6.4, and probably most of these as well. Predict which one would have the lower boiling point. Yes, so all of these practice problems here are going to be good because it's having to apply your knowledge about intermolecular forces to boiling points. Section 6.4. Yes, I do have questions from this section as well. So make sure you know about your saturated fats and your unsaturated fats and how intermolecular forces affect the structure of each of those. I don't have any questions from this section on intermolecular forces in the cell membrane. Okay? So on to Chapter 7. Chapter 7 is about solutions. So the first thing you need to understand about solutions is what the parts of a solution, understand what the solute is versus the solvent, being able to identify those. I don't have any questions about colloids and suspensions or homogeneous mixtures because we already kind of did that in the beginning when we talked about mixtures in Chapter 1. 7.2, formation of solutions, solubility and temperature, solubility and pressure. I have no questions on this section, on 7.2. No questions about that stuff. Section 7.3. You should understand what strong electrolytes are. Like what strong electrolyte, weak electrolyte, non-electrolyte, the difference between those. I don't have you writing any balanced equations in this section. Nope, I do not. So, but understanding that part is kind of critical for understanding some of the acid-base stuff. So don't completely skip over it, but no need to focus on it. You do need to know, so 7.2, 7.3, not a focus on the test. 7.4 is, you do need to know how to calculate concentrations. There will be some math. And I will even tell you the ones you should know. You should definitely know percent concentration. You don't need to know all this equivalent stuff. I don't have any questions about that on the test, about the equivalents and millimoles. You should know and be solid on problems that involve percent concentration. And you should know what molarity is, wherever that was. I don't have any on parts per million and parts per billion, but I do have a question about molarity. Where is molarity? Here it is, molarity. Yes, so you do need to know molarity, and you do need to know percent concentration, okay? So focus on questions. So in these practice problems here, focus on the ones that ask you about calculating percent concentrations, whether it be percent mass per volume, percent mass per mass, whatever it is, work on them. And also on what molarity is. But not necessarily these ones about milliequivalents and millimoles. You don't need to focus on those because those are not on the test. You do need to know how to do dilution problems. There is a dilution problem. So that's 2 math problems there. And you do need to understand osmosis and diffusion in terms of the cell, understanding what isotonic, hypertonic, and hypotonic solutions are, and the consequences, so how water moves into or out of cells in each of those situations. And that's it. I don't have anything on 7.7, the stuff about different types of transport across cell membranes. I don't have any questions about that. Okay? So just to summarize, Chapter 7, you do need to know the different parts of a solution. You don't really need to know, I don't have any questions from 7.2 or from 7.3. I do have questions from 7.4 specifically about molarity and about percent concentration. I do have a question from 7.5 about dilution. I do have a question from 7.6 about osmosis and diffusion. I do not have any questions on the test from section 7.7 about transport across cell membranes. All right. And lastly on the test is Chapter 8. Chapter 8 is all about acids and bases and buffers. So section 8.1, yes, you need to know definitions. You should understand the definitions of acids and bases and be able to identify an acid and a base in a given equation. So practice problems here are good practice. You should know the difference between strong acids and weak acids, or strong bases and weak bases. So that's the first part of the chapter. Section 8.3 is all about equilibrium, chemical equilibrium, which is a little bit mentioned in the last chapter in solubility equilibria, but we build on it a little bit in this chapter. You do need to know what the equilibrium constant is and how to calculate it for a given reaction. So practice, do these sample problems here, this sample problem here, and this sample problem here. You also should understand Le Chatelier's principle. So this whole section is definitely good to know, and to work on all of these practice problems, okay? Understanding equilibrium, how equilibria shift. Section 8.4, weak acids and bases. I don't ask you anything about Ka. I do, however, ask you a question about conjugate acids and bases. You should, given an equation, be able to identify the acid, the base, the conjugate acid, and the conjugate base. So do some problems practicing that. Here's some a sample problem here, some sample problems here, and some practice problems here that all help you to identify conjugate acid-base pairs. Those are good practice. Understanding pH, what pH is and how to calculate it. I do have a problem where you have to calculate pH, so you do need to know how to do the math and do log on your calculator. So here you go. We're calculating pH again. So know how to calculate pH. Know what pH is. Let me go back a page. Know the pH, what pHs are acidic and which ones are basic. I mean, you have your book, so I guess you don't have to memorize it, but understand what that means. This part gets a little complicated. I think I probably got a little confusing during the lecture too. About pKa and the relationship between pH and pKa. So I don't have anything on 8.6 or 8.7 about amino acids. Just know in general that amino acids are weak acids. They have a carboxylic acid group that makes them a weak biological acid, because that's something that's just kind of generally important to understand moving on into the next section. The next unit, we're going to be talking about proteins and amino acids. So I don't have any questions on 8.6 or 8.7, but 8.8, you should know what a buffer is, understand buffers. And I'm missing something. Let me go back for a second here to where Le Chatelier's principle was. Here we go, temperature. Yeah, so know this. Make sure you know Le Chatelier's principle, that section very thoroughly. Okay, so in summary, let's go to the summary section of the chapter. 8.1, definitions of acids and bases. Yes. 8.2, strong acids and bases. Yes. 8.3, chemical equilibrium. Yes, definitely know that. 8.4, weak acids and bases, understanding conjugate acids, conjugate bases, base pairs, those definitely. pH and the pH scale, being able to calculate pH, yes. Section 8.6 and section 8.7, no. I do not have any questions on those. So if they are overwhelming, then you can bypass them. And 8.8 is all about buffers, and yes, you should know about buffers. Okay, so hopefully this is helpful. Hopefully you took some notes during this video, and you have a better idea of what is going to be on the test and what to prepare yourselves for. And if you have any questions, call me, email me, text me, whatever. I know that this course, I think of all my courses, is probably the hardest one right now to try to be doing online. So make sure that you are staying on top of the material, contacting the tutors that I told you about, and meeting with them to get help, because it takes a lot more time to struggle through the material on your own than it does to meet with someone who can help explain it to you, okay? So please, please, please be proactive and be, advocate for yourselves in this. Because once the test goes out, once I post this test, you cannot get help from other students. And if you do, it will be considered cheating, and you will receive a 0 on the test. So make sure that you work independently. And you have open notes, open books, so you should do very well. I expect you guys to do very well. It's not a super hard, overwhelming test. So that's all. Bye.